I'm not going to give you solutions to homework 9.3, but maybe some tips that could help get you started in case you're stuck. They want the area of the shaded figure. In example 1, that's kind of a funky shape. We don't know how to get the area of that shape. However, we do have this rectangle, and we can get that area. And we do have on the sides some right triangles, and those are also shapes that we can get the area of, and they are marked as congruent, and we have 2 of them. So we can subtract the 2 triangles, and that would leave me with the area of the figure that's in gray. The second question, we have a square, and we have a bunch of boxes inside of it. So I could get the area of the square, and inside of it I have a whole bunch of boxes, or circles, I'm sorry. And if I took those 4 circles out of the square, I would be left with the shaded region. So it's the square minus the 4 circles. And those are the areas that we need to use. Next, we have a rectangle with a rectangle inside of it. So we're going to have to get the area of this large rectangle. Sorry, that's actually a square. But if we take the area of that square minus the area of this rectangle, we're getting rid of it, we would be left with the shaded region. Next one's a little bit tricky. We know that we have a rectangle on the outside, so we got to start by getting the area of this rectangle. Be careful because the full sides aren't given. You're going to have to do some adding. We have to start with that, and then we have to get rid of some pieces. And this piece is a half of a circle. Well, its partner is right there. And if I have 2 halves of a circle that I'm taking away, I'm really taking away that full green circle. And that has a radius, a diameter, I'm sorry, be careful with that. It's a diameter of 5. So the other piece is a different circle. Up here we have a semicircle that we have to cut out. So we're going to have to get rid of that piece. And if we take the blue minus the green minus the pink, it will leave us with that gray shaded region. Next one. 2 squares with a side length of 5 meet at a vertex, and together with segment AB form triangle of base 6 is shown. So they're describing the picture. Find the area of the shaded region. Well, this question is made of 2 squares, 5 by 5 squares. They're both the same. So we have 2 of those squares, and then we have to add in that triangle. Now to get the triangle, we have the area formula of 1/2 base times height, but I don't currently have the height of this triangle. However, I do know that if that's a square and that's 5, this is 5. Making this an isosceles triangle, we would probably draw the height in right here. And in an isosceles triangle, this is going to split up 3 and 3. And we could do a little Pythagorean theorem right here to get the height of that triangle. And once we have the height of that triangle, we can get the area of that triangle, add it to the 2 squares, and we have the area of that figure. The next one is similar. Wood pieces are nailed together to create a sign in the shape of the arrow. They're nailed together so the rectangular piece overlaps with the triangle by 4 inches. So that question is a little bit evil because it's not just the rectangle plus the triangle. It's actually saying that the rectangle overlaps this triangle. It cuts into it by 4 inches. So that is really my rectangle right there. So when I'm doing the area, it's not just the triangle plus the rectangle. we're actually going to have to take the area of the triangle. That's my first piece. I could get that area of this green triangle. And I'm going to add in the area of a rectangle, but not the rectangle that you were given. The rectangle I'm adding to the triangle is this one. Now that's not my blue rectangle. It's 4 inches shorter than my blue rectangle. So it's, if I were to draw them next to each other, it kind of looks like this. So the pink one is 4 inches shorter than this. And something to be careful of in this question is that we have units mixed together. We have inches, 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 and then feet. Well, 2 feet is 24 inches. So look out for that when you're solving this problem. And the last one. We are building a wooden deck around a circular swimming pool. He needs to know the area of the deck so he can find cans of stain. What is the area to the nearest square foot of the deck? That's our first question, and that's going to help us answer the next question. So first, we have to get the area of this deck, and the area of the deck is going to be a rectangle minus, not the full circle, but just half of a circle. We'll make it blue because it's a pool. So that gives me the area of the deck. That's going to help me figure out this area. But that's not what the full question is asking. It says that each can of stain covers 85 square feet. How many cans must Juliana purchase? Mr. Juliana. So we can figure out the full area, and then if we know that it covers 85 square feet, we can divide to figure out how many cans. Things to keep in mind. How many cans implies rounding. You cannot buy a partial can of paint. And so consider that when you're looking at your answer and you're deciding how to round it. No partial cans of paint allowed. We have to buy a full, or stain, sorry. We have to buy a full can of stain.